How much charge would have an energy of 25 kilojoules across a potential difference of 9 volts? Okay, so a couple things going on here. But again, we always start by looking for what we have and what we need. We're looking for charge. So that's Q. We don't know what Q is. Q is what we're solving for. Okay, but what do we know? Energy of 25 kilojoules. And as soon as you see metric prefix, little alarm bells will go off to remind yourself you're going to need to convert that to get SI units afterwards. And we have potential difference of 9 volts. Okay, so we're solving for Q. So if we remember our formula triangle, or even just look at the form of the equation, E equals Q times V. That was strange looking either. So that's not in the format we want. We want it in terms of Q. Basically, the way we get that is divide both sides by V. And we get Q equals E over V. And that's the form of the equation we want to work with. We plug in our numbers. We'll get an answer. Now, if all we use is SI units, our answer is going to come out in SI units. The SI unit of charge is a coulomb. So our final answer needs to be in coulombs. But that's only going to work if we use SI units, which is fine on the bottom. Our volts are SI units. But 25 kilojoules isn't quite. A joule is an SI unit, so we just need to do the conversion by kilo means by 1,000 joules, right? So once we plug that in, then everything's working out nicely. Okay, so we've got 25,000 divided by 9. That's not going to necessarily work out super easily or well. You might need a calculator, and that's always okay. You have to use a calculator to answer these questions when the numbers aren't nice. So we can type that right in. And unfortunately, my calculator is a little too big for the window I made here, but I'm going to go 25,000 divided by 9 equals, and we get an answer that's not super nice. Generally, we can round off to just a single decimal point, especially if it means we have, as we're going to in this case, 5 significant digits. Okay, but it's 2 7/9, so 2,700, and we can actually just round it off to the nearest coulomb here, 2,778 coulombs. And that's our final answer.